Hello and welcome to this introduction to Arduino. This series mirrors presentations and demonstrations I've developed for a local hackerspace here in Tucson. The original series is made up of 3 PowerPoint presentations, which are now broken into 10 chapters to fit this venue. The chapters approach Arduino from the point of view of someone who knows nothing about electrical engineering, similar to where I was 2 years ago, and slowly walks you through what you need to know to graduate your ideas into real-world applications. Since I'm a hydrologist and not an electrical engineer, some of the concepts I share speak to how similar electricity is to water flow, and then follow with questions and answers I had during my own learning experience. In this way, hopefully, you can get up to speed quicker than I did, since you'll be learning from someone who's essentially self-taught. The point being that if I can figure this out, not being an electrical engineer, I'm sure you can too. So this basically is a summary of the 10 chapters that we'll go through for this series. The original series, as advertised at ZeroCraft, is Introduction to DC Electronics and Arduino, the basics. And this first chapter is basically a summary of what Arduino is and what we can do with it. So this is the platform that we're talking about. And the really cool thing about it is that both the hardware and the software are licensed under Creative Commons open source framework. And what that lets you do is take this platform, take the work that other people have done and build upon it. You can take your invention and you can essentially sell it, or you can give it away. But the nice thing is you don't have to pay any licensing fees to the people who built the original platform. That's really powerful, it opens up all kinds of opportunities. Essentially, if you can think it, you can probably do it. It's like scratching your own itch. If you have an idea, you just go and make it. It's one of the founders of the platform conveyed during a TED Talk. This is the equivalent of sketching on paper with electronics. And there's a great video that you can watch on YouTube. There's the link down below where you can get more information on the same. Okay, so let's take a closer look at what an Arduino is. That long black chip that you see in the lower center part of the board is the microcontroller. And what you can do is you can attach environmental sensors to socket headers. Usually you would attach those to the analog in socket headers located in the lower right. And then you can write a program that you can upload into the microcontroller to record and respond to the data that's being registered by those environmental sensors. And then depending on conditions that you specify in your program, you can engage motors, servos, LCD displays, cell phones, servers, all kinds of different things, which you control programmatically based on things that are happening in the environment. And this is another example of how an Arduino works. In this case, I have a sensor, specifically a microphone, that's attached to a breadboard, and we'll talk about breadboards in another chapter. But you'll notice that I have wires running from the microphone to inputs in the Arduino. And in this case, I've uploaded a program to the Arduino to respond to sound waves in the environment. And when the microcontroller detects those sound waves, it'll light a suite of LEDs based on conditions that I've specified in the program. So a real simple example of taking environmental data, processing it, and turning it into an action, in this case lighting LEDs. And this is a very simple example. I have more complicated real-world examples that I'll share in a future video. So Arduinos are pretty ubiquitous. If you're wondering about where to purchase one, you can even buy them on Amazon. You can see that they're relatively inexpensive. This is $16 for an official Arduino Uno R3 from the original Arduino Foundation that created this technology. And that's amazing that you can purchase basically a computer that can sense and react to the environment for such a small amount of money. Having said that, you can also purchase these Arduino clones on eBay. Since the original Arduino was licensed under Creative Commons, people have made clones available. You can have these shipped to your house for less than $4. It takes about 2 weeks for these to come in from China. I don't really recommend these for people who are first getting started because There are, in many cases, there are drivers that you need to download off the internet to get them to be recognized by your computer. You're better off just starting off with an official release and avoiding all those headaches. And later on, when you get smart and you feel comfortable with the platform, you can start playing with these clones. So Arduino comes in all kinds of different shapes and sizes as well. The official Arduino Uno R3 release has a lot of stuff on that printed circuit board that you may not need for your given application. So companies like OutofFruit have created simpler versions of Arduino that eliminate a lot of the overhead hardware that you may not need for your application, and they're also less expensive as a result. And they may also consume less power if say you're running your application off a battery. So these are nice alternatives. At the same time, keep in mind that because it doesn't have all that hardware overhead on it, they may be a little bit more difficult to program or to play with when you're first starting out. So again, start out with an official Arduino Uno R3 when you're first starting out, and then you'll understand the costs and the benefits of working with something that has a different form factor, such as the trinket that's offered by OutofFruit. So one of the really nice things about the Arduino Uno R3 platform is it allows you to stack different technologies on top of that platform. In this case, I'm showing a battery shield, so it's a shield that can fit on top of that Arduino with a battery and a switch, so I don't have to be tethered to the wall or to my computer. I've also got on the top, I've got what's known as a FONA shield, which allows me to add a cell phone essentially to my Arduino. And then down below I've got an LCD with buttons. And that allows me to basically create an LCD screen that shows inputs and outputs generated by my program. And this is essentially what all those different shields look like when they're stacked on top of the Arduino. You just create one nice little compact piece of hardware that will do what you've designed it to do. In this regards, Arduino is a lot like Legos for electronics, is the way I see it. You don't necessarily need to know, how the plastic was made or all the electrical engineering that went into those specific shields. You just need to have a little bit of background in electronics to basically understand the opportunities and the limitations of how to stack these shields on top of one another. Similar to, there being a strategy to building an effective wall out of Legos. The other nice thing about Arduino, and particularly this vendor, who's one of my favorite vendors, OutofFruit, is sometimes they'll take all those different shields. They'll see that that there's an opportunity to incorporate all those shields into something very small and compact. In this case, what they've done is they've taken an Arduino and embedded a cell phone all into this one little board, so you don't have to buy a big Arduino Uno R3 and then attach a FONA shield on top. It's all basically integrated in this tiny little printed circuit board. That's really powerful that you have something that can do so much in something that's not much bigger than your thumb. So when I first started getting involved with Arduino, I was a little skeptical. I wasn't sure if Arduino could really, if it was really up to the task for my applications. In my field as a hydrologist, I'm really interested in weather monitoring, stage alerts and ephemeral washes and things of that nature. But doing a little bit of research on the web, I found out that Arduino is very common actually. It's a common component in weather stations and tide level alerts. There's a lot of information that you can get out there from Makershed Press on how to build and program environmental monitors for relatively little money. In fact, there are even projects out there on the web that are targeted to 5th to 12th graders for, say, air quality monitoring. This is one project in particular that was developed by the EPA, and that just blows me away that kids, can actually build air quality monitors off this very cheap and inexpensive technology, and with the same being promoted by EPA. It's just amazing to me. In fact, I was blown away by the fact that Arduino boards are also used at CERN for collecting sensor data from the Large Hadron Collider. That sounds like pretty robust technology to me. In my case, what I'm interested in doing is creating some kind of flow alert system for ephemeral washes in southern Arizona. As I mentioned, I'm a hydrologist. We like to sample these washes when they flow for water quality. And sometimes it's kind of hard to know when these are actually flowing. So we may take long hikes during the rainy season to some of these remote sites just to come upon a dry wash like the one seen here. Having said that, there is technology out there that serves the environmental monitoring community. This is a data logger made by Campbell Scientific. It's a great company. They make great hardware, but it's also expensive hardware. This data logger costs about $1,500 just for the hardware. In comparison, for someone like me who doesn't have that kind of money to do environmental monitoring, I can actually purchase a data logging shield for an Arduino for about $20. And what this data logging shield does is it allows me to insert a little camera card and allow my Arduino to collect environmental data and store that information on a camera card that I can then later on attach to a computer and get all that same data that I might get from a $1,500 data logger from Campbell Scientific. Now, for remote monitoring of those ephemeral washes that I mentioned earlier, another great company out there, Teledynisco, makes these cellular modems that can talk to auto samplers and that can send information to the internet or to my cell phone when a flow event has been registered and has triggered the auto sampler, and basically notifying me that I should go out and collect a sample. The thing is, once again, this is relatively expensive hardware. For just one cellular modem, I'm looking at about $2,300. And that's just money that I don't have, particularly if I want to do environmental monitoring all over the watershed. That'd probably be my entire budget for the year just to install one cellular modem out in the field. And this is really where my interest in Arduino comes in. The fact that I don't have a lot of money to do environmental monitoring, and yet Arduino offers me the potential, it offers me the platform to basically build a $2,300 cellular modem for remote environmental monitoring, and I can do it on this platform for under $200. When I'm faced with the option of buying one cellular modem for $2,300 versus maybe building 15 of these on my own, which I can disperse all over the watershed, I think that really speaks volumes to the potential for this platform and for Arduino in general. And again, this just speaks to the potential of Arduino to do exactly what I'm trying to do at much lower cost. I have, in fact, built these remote environmental monitors. They operate under solar power that charges a battery and allows me to install a sensor in an ephemeral wash and let me know when a flow event is taking place in that wash and when I should go out and collect a sample. And the beauty of this is I've managed to build these for a little around $200, a much better alternative than $2,300 for a commercial option. And again, speaking to the potential of Arduino, in my case, I'm interested in remote environmental monitoring. I've discovered that there's this website known as ThingSpeak, which is also Creative Commons open source. It's free for anyone to use. I can take environmental monitoring data that's being transmitted by a cell phone that's attached to my Arduino in the field, send it to the ThingSpeak server, and then I can actually monitor what's taking place in the field via a web browser that's talking to that ThingSpeak server. That's very powerful, and again speaks to the idea that if you have an idea or something that you want to execute, with a little bit of research and a little bit of sweat equity, you can actually pull it off. And these are just some statistics associated with that little remote environmental monitor that I've deployed out in the field. And again, demonstrating that the technology is very robust for applications that you can come up with. And the other nice thing about Arduino is that you're not necessarily married to any one given technology. In my case, I wanted to deploy these remote environmental monitors in areas where I may not necessarily have cellular technology, and discovered that there are these things called rock block modems that allow me to talk to satellites so that I can do environmental monitoring anywhere on the face of the planet at relatively low cost. That's just extremely powerful. So in summary, I spoke a little bit about what an Arduino is and applications that I'm interested in, really cellular and satellite telecommunications with the Internet of Things. But the truth of the matter is there's just so much more you can do with these Arduinos. I mean, I gave examples of things that I've played with related to my work, but I mean, there's so many other things that you can do. You can talk over Wi-Fi networks. You can incorporate weather sensors and LCD displays. You can turn on motors and servos if you're interested in robotics. Relays, infrared sensors for remote control applications. There's just so much you can do with this platform, and it would be very difficult for me to cover everything in a 20-minute introduction, but I think you get the idea. So if you are interested in other applications, all you need to do is do a Google image search for Arduino sensor and see what comes up. There are so many sensors out there that you can embed into your Arduino. GPS, just anything you can think of, and it really does kind of open up a brave new world for invention. So in closing, I just wanted to mention that although I hope you'll use this as a resource to help you get up to speed, there's a lot of resources out there on the internet, and one of my favorites is certainly OutofFruit. It's a wonderful company. They make a lot of the sensors that I alluded to available for sale. And the nice thing about OutofFruit is not only do they sell you hardware, but they also have some wonderful online tutorials that explain how to use that hardware, Arduinos included. So this is definitely a place you may want to visit. In fact, some of the forums that OutofFruit hosts have been really helpful to me personally. In fact, when I was first getting started, I had no idea how I was going to attach a cell phone to an Arduino, and I just would post the question on some of their user forums. And there's a wonderful community out there of people who are a lot smarter than me who actually gave me ideas on how to move forward, and it's thanks to that input that I was actually able to develop something with no background in electrical engineering. Of course, I don't want to forget the Arduino Foundation. If you go to this website, they also have online forums and support venues for people who have questions. And then there are a lot of resources online, a lot of really great books that can help you get started. These are my top 3 books that I've listed here. Make Electronics, Learning Through Discovery, Getting Started with Arduino, the open source electronics prototyping platform, Make Publication, and also Programming Arduino, Getting Started with Sketches. If I had to pick my top 3 references for getting started, these would be the ones. These are the ones that have really helped me, get my wings. But the others that are listed are also valuable. And again, there are a lot of online references for hardware, for online tutorials, and I've listed my top 10 here for both, with some guidance with respect to cost and comments regarding respective venues as I've discovered and used them over the years. And of course, as I'm sure you're well aware, there's a lot of stuff out there on YouTube regarding Arduinos. These are the top 3 TED Talks that I'd recommend to if you're looking for a little inspiration or further exploration of the potential for Arduino. And there are also a ton of how-to videos out there. My favorite are the Collins Lab videos, which the guy does a wonderful job of explaining electrical engineering concepts to non-electrical engineers like me. in a way that's entertaining and fun. I mean, they're just wonderful videos, and I highly recommend them. So in closing, this is kind of the format of what I hope to share as an introduction to Arduino moving forward. Really appreciate you guys sticking with this introduction, this broad overview. I'll get a little bit more into the nitty-gritty in the following chapters, and I hope to see you soon. Thanks.